Today you're going to solve quadratic equations by graphing and factoring. And I'm going to go over a few things here. The zero of a function is a value of the input x that makes the output f of x, or y, equal to 0. Now the root or roots of an equation would be the solutions to a quadratic equation of the form ax squared plus bx plus c equals 0. And those are the values that make the equation true. Now functions, so when we use f of x, we say that they have zeros or x-intercepts. When we make an equation like this without the f of x, set it equal to 0, we say that they have solutions or roots. So you'll see the term zeros or roots when you're talking about quadratic functions and quadratic equations. All right, finding zeros of a function from a graph is pretty easy to do. You're just going to look at the graph and find out where it crosses the x-axis. Now, unlike linear functions, which have no more than one zero, quadratic functions can have up to two zeros. And zeros happen where the graph crosses the x-axis. So if we're looking at this graph, there's two different parabolas on there. If we look at the one over here that's labeled G, you can see that it's crossing the x-axis at 1 and 3. Now when a function crosses the x-axis, y is equal to 0. So that's why it's called zeros. So we have zeros for G when x equals 1 or x equals 3. And if we look at the function f, it's just hitting the axis in one place, x-axis, and it's hitting at 0, and this is actually a double root, which we'll talk about later. So the 0 would be x. X equals 0 for the function f. Okay, now you try it. You can turn the video off for a couple seconds and then turn it back on again. All right, we're going to find zeros of a function by using algebra, which is a more accurate way to find zeros than graphing. And to find zeros by using algebra, you're going to set f of x equals x squared plus bx plus c equal to 0. And the solutions to the related equation represent the zeros of the function. And you can find the roots of some quadratic equations by factoring. So not all of them. We'll learn some different techniques later in the chapter for ones that we can't factor. And then once you factor, you apply the zero product property. And the zero product property just basically means when you multiply two things together, if you end up with 0, then the second one has to be 0 or the first one has to be 0. Another thing that could happen is that they're both equal to 0. So multiplying two things together and a product of 0, the first one has to be 0, the second one has to be 0, or they're both equal to 0. So let's go ahead and factor a quadratic equation and find the roots. And hopefully factoring you remember from Algebra 1. So the first thing that we're going to do with this function is we're going to rewrite a related equation, which means we're going to set it equal to 0. The second thing we're going to do is pull out the greatest common factor, or the GCF. If I look at all three terms, I have to be able to pull the same thing out of all three of them. I notice this one has an x, and this one has an x squared, this one has an x. This one doesn't have an x, so I can't pull out a variable, but I can pull out a 2. Out of all three of them. So that's what I'm going to do. And once I pull out that 2, I'm going to divide both sides of the equation by 2. So I end up with just x squared minus 6x plus 9. Now the third step says that I need to find factors of a times c that sum to b. So let's just line up our standard form for the equation of a parabola and line up the ABC. And as you can see, a is 1, b is -6, and c is 9. Okay, what this means, I'm going to make a little table, and I'm going to write a times c, so that's 9, and b is -6. Now make sure you take the sign with the number, otherwise you're going to run into some problems. All right, factors of 9. I could have 1 this off for just a second here. I could have 1 and 9. I could also have 3 and 3. Okay, now I want to multiply them to get 9. I want to add them to get -6. So that means I need some negative signs over here. If I put a negative sign here and a negative sign here, that's going to give me a positive 9 when I multiply, but it's going to give me a negative 10 when I add them. So that's not going to work. If I put a negative sign here and a negative sign here, when I multiply them together, I do get a positive 9. When I add them together, I get a -6. So that's going to work. Now basically what we're doing is we're foiling backwards. So we're taking this apart. Now I found the two numbers that I want to, let me right here, we want to rewrite B in terms of the factors that we found. So these are the factors that we want. We're going to rewrite just the -6. So rewrite, just drop down that x squared there. We're going to rewrite -6. We're splitting it into two terms. So -3x goes here, and then the 9 stays the same. So the only thing that changes is this middle term. I split it into two terms, and then the next step says that I want to factor by grouping. Well, grouping, we're going to group 2 at a time. And then I'm going to go back to pulling out a GCF. So I'm just looking at these two right here, and I can see they both have an x in them, so I can pull an x out. So if I divide this by x and I divide this by x, that goes here. This gives me x, and then x divided by, or -3x divided by x is just going to give me a -3. And then I do the same things to the next grouping, which is identical. So, or no, it's not identical. I have a -3 here. So always pull the sign out with the number. So if I'm looking at this first term, take the sign with it, which means I need to divide by a -3. That's my GCF. So when I pull that out, this is going to give me a positive x and then a -3. And if I would multiply that back out together, I would get a -3x plus 9, which is what I have right here. Now, when you get to this step, if you can factor, the parentheses should be identical. And then what you're going to do is you're going to take those parentheses out. So if I take this out, and I write it as x minus 3, you can see, or maybe you can't, it might be too dark. Let me just cover it up with a pen here. Just think of taking those two parentheses out, and what you have left is x minus 3. So let's do it this way. Maybe this will be better. I'm taking out an x minus 3 from both of them. So I only write it down once. There's my x minus 3. And then I write down what I have left, which is another x minus 3. And I set that equal to 0. Now before we go do anything else here, I'm just going to show you that this works. If I FOIL this back out, I'll end up with x squared minus 3x minus 3x and plus 9. And you see that in this step right here. So again, we're basically foiling backwards when we do this. And then we just combine like terms, and I have what I started with. Okay, now I'm setting this equal to 0. So that means if I have a product equal to 0, this has to be equal to 0. This has to be equal to 0, or they're both equal to 0. So that's my product property, 0 product property. So I'm going to set each one equal to 0, and then when I solve, I get x equals 3. And then the last step is just to check to see that it equals 0. So when I substitute these back in and solve, I can see I have 36 minus 36, which equals 0. All right, last thing I want to go over is practical application of finding the zeros of a function, and this is determining the height of projectiles on the Earth. So this is the equation. It's a very basic equation here, and it just approximates the height in feet of a projectile on Earth after t seconds. Now it has limitations because it does not take into account for any air resistance, wind, or any other real world. So this is just a real basic function for projectiles. All right, so you can see what each thing represents here. And we have a problem. We have a football that's kicked from ground level. So if ground level is going to have a height of 0, with an initial velocity vertical velocity of 48 feet per second squared. So if you come over here, you can see the initial velocity is v sub 0. So that's where that's going to go in. And the ground level part is the initial height. That's the height that you're starting at. Now you could say you're kicking it from a chair and that chair has 4 feet, then this would be 4 here. If you're standing on the chair kicking a ball, which I wouldn't recommend. Okay, so we want to know how long the ball is in the air. So we can just use this equation. This is not going to change in our equation. And this is, you'll get from your, it'll say initial vertical velocity, and that's what goes in for the v sub 0. The t represents time, and that's what we're trying to find. We want to know how long the ball is in the air. And again, the initial height, since we're standing on the ground when we kick the ball, the initial height is going to be 0. So that's where that comes from. All right. Now we can just do away with the 0 here. And if I want to find the zeros, I have to factor. Now there's only 2 terms here. So I'm going to pull out the GCF, and I can see they both have a t. So I know now I can pull out a variable. And the largest number that can come out of both of those is a negative 16. So I'm going to pull out a negative 16. And when I divide this by negative 16t, because I want to pull that variable out too. I want to take as much out as I can that they both have in common. And then I will be left with a t minus 3 equals 0. Okay, so multiplying these together, if they equal 0, this has to equal 0, this has to equal 0, or they both have to equal 0. So I'm going to set each factor equal to 0. So I have t equals 0. So before I even kick the ball, t equals 0, it's going to be on the ground because it's starting there. And then the second one is after 3 seconds, so it's going to get kicked, it's going to go up like this, and then after 3 seconds, it's going to be on the ground again. So the time equals 3, or t equals 3, so that means 3 seconds is the answer to my problem. Okay, so you have a problem to factor, and you have a problem similar to the one that we just did.